All right, so universal gravitation, planetary motion. We've got two satellites of masses m and 3m, respectively, are in the same circular orbit about Earth's center as shown in the diagram. Earth has a mass of me and radius re. The orbit has a radius of 2 re, and the satellites initially move with the same orbital speed v0, but they're in opposite directions. We can see the problem coming. Calculate the orbital speed v0 of the satellites, and you have to keep it in terms of the constants given plus the universal gravitational constants. Assume there's a head-on collision and they stick together, so we're going to find their new speed. And then calculate the total mechanical energy of the system immediately after the collision, and assume that the gravitational potential energy of an object is defined to be 0 at an infinite distance from Earth. So that's holding up what we already know. Okay, let's take a look at this rubric then. Okay, so first of all, we're going to use Newton's law of gravity to find the force that's acting on each of these satellites, because it's that force that's causing the centripetal force, which is causing the centripetal acceleration, which then gives us the velocity. So we're going to set those two equal to each other, the centripetal force and the gravitational force, which then allows us to solve for the initial velocity. So a point for using Newton's law of gravity, a point for using centripetal acceleration, a point for setting the gravitational force and centripetal force equal to each other, and a point for then substituting incorrectly for the radius, that it's 2 re, and then solving for the initial velocity. Gets you a point. So 5 points for part A. That's a nice hefty chunk. For part B, we're going to use conservation of momentum. Anytime there is a collision, use conservation momentum. Make sure you make some statement showing that the momentum is conserved. It does not matter what kind of collision you have, momentum is going to be conserved. So we have our initial momentum each. Notice there's a minus sign because the velocities are in opposite directions. That's important. You then have a total mass that's combined. Okay, so 2 points for the correct values of the momentum and 1 point for the minus sign. Then solving correctly for the new velocity gets you another point. Okay, then part C. Okay, if you notice here, this first term within our energy equation, this is the kinetic energy of the system. This would be our potential energy of the system. The potential energy is negative because it says it's going to be 0 if you're an infinite distance away. So that's why this is minus instead of plus. Okay, so 1 point for knowing that it's the sum of the two energies. 1 point for knowing the energy is both kinetic and potential. 1 point for having the correct mass of 4m in there. 1 point for the radius being correct, the 2 re. And then 1 point for having the gravitational potential energy as negative. Then 1 point for solving the algebra correctly. So those are your points for the Unit 8 FRQ.